Alrighty, so today we are going to talk about proving the properties of parallelograms because remember, properties are proved based on the definition. That was the difference between a definition and a property. A definition is just something that I give it to you and it is what it is. And property was if we could go to that desert island where the people don't know geometry and you could tell them, hey, a parallelogram has two pairs of parallel sides, and they could figure out all the properties based on that definition. Okay, so today we're going to prove those. So just to get your mind working on them, okay, remember the triangle congruence theorems. We have side, side, side congruence, side, side congruence, angle, angle congruence, and angle, side congruence. And those were to have basically shortcuts to show that triangles were congruent. So if I could show that, the three sides of a triangle are congruent to the three sides of another triangle, I didn't have to show that all the angles were congruent because just having those three pieces of information was enough to show that the triangles were congruent. So in this case, I've got one pair of congruent sides, another pair of congruent sides. This side in the middle is going to be congruent to itself because it's shared between the two of them. So that makes this congruent by side, side, side congruence. Okay, this one in here, don't forget, if it's congruent to itself, that property was called the reflexive property. Then alternate interior angles was whenever you had parallel lines, and they had to be parallel, and then you had the transversal going over them. And so these angles right there would be your alternate interior angles, or another pair of alternate interior angles, the ones right there. Okay. And remember, when they came over parallel lines, they had to, or the alternate interior angles are congruent, but you have to have those parallel lines first. It's interesting that we're talking about parallel lines because we have a parallelogram. Okay, so to do these proofs, property number one, this is on your guided notes sheet. I'm just going to do the flowchart first, and then we'll convert the flowchart into the two-column proof, which you have space for on your paper as well. Okay, so property number one, I'm going to want to show that the opposite sides of a parallelogram are congruent. So, and notice my given is simply just that ABCD is a parallelogram. So literally, I'm going to prove everything just based on the fact that it's a parallelogram, and I know what the definition of a parallelogram is. I'm going to prove that this side is congruent to this side. So it's proving that one of my pairs of opposite sides is congruent. Now, obviously, if we wanted to be completely thorough, we would also want to prove that these sides are congruent as well. The nice thing is, though, is once we do a proof for one of the pair of opposite sides, what mathematicians most often do is see the same proof, and then they write down what the different result is, because the proof is exactly the same to prove the other pair of sides. So we're just going to prove this pair of sides here. So to start out with, remember our whole setup here. These over here were your sides and angles. Once you had your sides and angles, you could prove that the triangles were congruent. And once you proved the triangles were congruent, you could use CPCTC to prove that whatever else it was, this means our two sides are congruent to each other. And remember that CPCTC stands for corresponding parts of congruent triangles are congruent. This is saying basically that if I have the congruent triangles, which you would have shown before that, then I have all those corresponding parts, those sides and angles that are congruent to each other. Okay, so I'll go ahead and go backwards here. So we know that this is and we know that it is AB is congruent to CD. Okay. So backing up one step, that means that I need some triangles that are congruent. So in this case, it's going to be triangle ABD is going to be congruent to triangle CDB. But I have to come up with what congruence theorem that's going to be. Well, looking at this diagram, okay, I know that this side is parallel to this side, which means I have a transversal crossing over them, which means this angle and this angle are alternate interior angles, which means that they're congruent. And I know that this side is parallel to this side, so that means that this angle is going to have to be congruent to this angle because they are alternate interior angles. All right, so I've got two angles. My last thing here, notice BD is shared between these two. So let's make it just congruent to itself. So here we go. I got ASA for my congruence theorem. So angle, side, angle. Use angle, side, angle. That means that over here I'm going to have an angle, a side, and an angle. And my first pair of angles there, I have angle A, C, angle right here. I'll say that that is congruent to angle, this one down here, CDB. Remember that those are alternate interior angles. Okay. My side, well, it's that side in the middle, so BD is congruent to BD. And you know from your bell work, that's by the reflexive property. And last but not least, I have this other pair of angles here, this angle and this angle. So that's going to be angle ADB is congruent to angle CBB. And that is also the alternate interior angles. So there we go. There's our flow chart proof. Okay. And to convert it over to the two-column proof. Now, the reason why I'm having you do two-column is I'm going to test you in two-column. Okay, so I know whenever we did the triangle congruence chapter, we did mostly flowchart proofs. Okay, for this chapter, I'd like us to move towards doing two-column proofs. That way, we're more well-rounded provers. We can do it in a lot of different forms. Okay. But the nice thing is once you write it in flowchart, it's literally just copying the flowchart into the two-column. Okay. There's going to be one exception. I'm going to add in a different step number 1. Okay. And what that is going to be is basically using that definition of parallelograms. Because remember that one of my justifications is alternate interior angles. Well, I can't have alternate interior angles that are congruent unless I have parallel sides. So just for the sake of being thorough, I'm going to make sure that I say, hey, the opposite sides are parallel to each other. So AB is parallel to CD. And that other pair of opposite side of AD is parallel to BC. And that is just by definition of a parallelogram. And then now you just go back to your flow chart and start copying things in. So our next step here, we read a flow chart from left to right. So my top left here, I have these two angles. Now since this step and this step have the same justification, I'm just going to combine them into the same step. My two columns, just to make it easier. Okay. So angle ABD congruent to angle CBB, and angle ADB is congruent to angle CBD, and both of those were by the same justification, alternate interior angles. All right, step number 3. Okay, reading it from left to right. So I've taken care of these two angles. Now I need to say something about that side. So we've got BD is congruent to BD. The justification for that one was the reflexive property. Okay. Come back here. So I've taken care of all these. So all these arrows lead into this one right here. So I need to talk about my triangles next. So step number 4 is going to be triangle ABD is congruent to triangle CDB, and that is by angle side angle congruence. And last but not least, so I've talked about this one, so now our very last step is this one right here. So we're going to have to say that our opposite sides, which are AB and CD, are congruent, and that was by corresponding pairs of congruent triangles are congruent. There it is. There's our proof. Okay. Now the neat thing about having this proof is because when we go on to prove property number 2, I'm proving that the opposite angles of the parallelogram are congruent. But notice something here. This diagram, compare it to the diagram for property number 1. It is. It's the exact same. Okay. Notice my givens. I've given that ABCD is a parallelogram. Look at your givens for property number 1. That is exactly the same. Notice that angle A and angle C are both part of the same triangles that we proved congruent for property number 1. Yeah, this property's proof looks exactly the same as the proof of property number 1, except for our last step down here is going to be that angle A is congruent to angle C instead of those two sides were congruent. Okay, so it's kind of cool. You pretty much use the exact same proof for 2 different properties, which is awesome. So I'm just going to fill this in real quick for you. You can just copy property number 1 we had those two triangles were congruent. And remember, it was by angle, side angle. And remember over here that we would put our angles that were congruent by alternate interior angles. So this would be angle ABB, congruent to angle CBB. The alternate interior angles at AB, which is congruent to BD, by the reflexive property. And then as well as that angle AEB, by alternate interior angles as well. So if you call proof on your own, literally, it looks exactly the same. This is what you're calling proof for property number one. It looks exactly the same, except for you just like to change this part right here. Okay. So go ahead and fill in the two column proof for property number two at this time. Pause it and then come back to me. Property number four. You might see that we skipped property number three. Okay, that was on purpose. Properties 1, 2, and 4 have very similar proofs, so it's neat to do them all together and see the similarities between them. Property number 3 has a very different proof for it. Okay, it's a very cool proof. It really works out very nicely. It's very algebraic in its approach. And so, if you would like me to show it to you, I would be more than happy to do that. Just let me know. Okay, but for now, we'll just skip it for our notes. Okay. So property number 4, notice that I'm proving the diagonals now bisect each other. So I've got both of the diagonals drawn in. And to show that the diagonals bisect each other, because bisect means cut in half, I'm going to show that DE, DE is congruent to BE. Okay? Because if I show that these two parts are congruent to each other, that means that this diagonal is cut in half. Okay? It's same as that discussion we had for property number 1, where I said, well, technically, then I'd have to go back after the proof and say that the other pair of opposite sides were congruent to each other. Well, same thing here for this proof. You would go back and you'd have to show that AE is congruent to EC as well in order to be thorough and show that the diagonals bisect each other. However, the proof looks exactly the same. You just have a different last step. Okay? So we're just going to do it for BE is congruent to DE and just know in our minds that it works for the other ones, and this proves that the diagonals bisect each other. Okay. So let's start with what we probably know off the bat. Our last step is going to be that B is congruent to BE. That is a CPCTC. Okay. The triangles we're going to prove are congruent to each other. We're actually going to prove these smaller triangles now. We're going to prove that AEB are congruent to each other. Okay, so it's going to be triangle AEC is congruent to, I'm sorry, B. It's congruent to triangle CED. Okay. This is going to be by, well, let's think about this for a sec. We're given that it's parallelogram again, so we know that we have this line parallel to this line, which means I've got another pair of alternate interior angles again. That means, though, I've got this other transversal drawn in right here. That means that these are alternate interior angles as well. Now I just need one more thing. I know that these angles are congruent because they're vertical, but that doesn't help me get a congruence there. So what I'm going to do for this one is something not that I want to do for properties number 1 and 2. Because properties number 1 and 2 come first, I could not use the properties to prove themselves. That's like arguing that I didn't do it because I didn't do it. It's just not a real strong argument. However, since property number 4 comes after that we've proven that the other two are congruent to each other, then I'm going to go ahead and say that by properties of parallelograms, that side is congruent to this side. Okay? So angle BAE is congruent to angle DCE. Those are alternate interior angles. And then I'm going to say AB is congruent to CD. And this would be by the properties of parallelograms. And then last one is another pair of angles. So angle ABE